So, everyone, our team is currently on the pad. Sorry that the setup took so long. We only recently got the generator to work and refueled. So in the back, I don't know if you see above the logo of Makerspace right now and above the banner, there is like a green flag behind the bushes. That is where the Launchpad is. And we are essentially setting up right now. So the pad should hopefully be ready within like 10 to 20 minutes. So afterwards, the flags will continuously change from green to to yellow and then to red. When you see red, you might see a lot of cars driving by as they are clearing the pad. They are coming to us, to mission control, and when that happens, we are essentially clear for launch. So soon we will be actually launching the rocket. The timer here is again preliminary, as we are not getting that many updates from the pad currently, but yeah, we will soon see our rocket fly. So stay tuned. That's so hilarious. Like it's just standing there.
Yeah. Just hanging around.
Okay, is everything set up from our side? Besides EXUI and all of that? What? Besides... Are we, in terms of PR, ready? Yes. In terms of PR, we are ready. We actually have a running stream now. I will...
And the link didn't change for the embedded stuff?
Link...
Didn't change,
I don't think so. Let me check. No, it shouldn't have.
Okay, as long as Ludwig isn't complaining, it's a good thing.
Okay. Actually, since not much is happening on our pad right now and the only thing visible is kind of the green flag, we are actually launching rockets right over to our right side. Wait, let me just quickly... Yeah! Sorry that I couldn't catch it with the main camera, the countdown was just coming low. I will try to catch the others though. They launch them essentially in sequences, so essentially when a deployment of the drogue is confirmed, they launch another rocket. So I will try to get the camera set up in position such that you can see the launches, and yeah, hopefully if everything goes good, we will see some rockets fly before ours. Of course, still the main event remains our rocket, which is being right now prepared on the pad, and yeah, hopefully within like 30 minutes we'll be ready to launch. Let me actually try to max out the mic such that you can at least try to hear the rocket.
Am I in front of it?
Three, two, one. Okay, so the drogue apparently on this rocket deployed successfully. Yeah, not much other that I could catch from the live stream, or they're essentially directly streaming the radio directly to our spot. I don't know how much of that you could hear. However, yeah, so that is here happening continuously. So yeah.
Soll ich die ausrichten? Guys! Yeah. We have to adjust it. Has to freeze the pad.
Five, four, three, two, one.
We have more tape to stick it in this position. Habt ihr alles Tape?
Aaron, can you see if they're taping that box?
Okay, wir versuchen das natürlich so zu festigen, die Position.
So, quite some live action here. Yeah, I have a few things to solve. However, I will ask one of my compatriots to kindly take charge of the camera and try to track the rocket while we attempt to resolve a few last issues. I don't think I can take it much further. I can try to put this here.
Okay.
Yeah. Okay, perfect.
That's on your way.
Superb. So I hope you are enjoying yourself. I don't know how well I could track. Sadly, the camera monitor, the camera display is kind of hard to see in these conditions. So yeah, unfortunately, we do not have quite the setup here for that. Yeah. However, we will try to show you as much as possible, of course.
Nicht hier, ich glaube, es hat auch alles Peeling mitgenommen.
Currently focused on a bush. What? I think we can try. So rapid unscheduled disassembly was declared on this one. There was some wobbling at the end of the burnout. Maybe a fin broke off, unconfirmed. But yeah, this was quite a wild ride. Okay. So in the meantime, let me explain to you what's happening with us. If you haven't watched the stream from yesterday, we are a two-stage rocket. That's why we are actually shifted a bit from the original pad, which is way, I think, about 500 meters in the direction that the camera is currently pointing in. You have somehow embedded a window inside.
Oh, that's the something that's the manual focus.
Oh, okay.
Inside.
Yeah. So, with regards to what's happening with us, we are currently putting the two stages together, preparing the igniters for the rocket. So we have two igniters instead of one, of course. As for each motor, we need a separate igniter, and since we have two stages, we have two motors. With regard to the flight, so we will at first burn 3 seconds with our booster. That is going to push it at 8 kilonewtons, 12 Gs of acceleration. And then afterwards we separate by drag, and the second stage ignites. We should, with this configuration, go to about 28,000 feet, if I'm correct, maybe a bit lower, and essentially attempt to. Okay, yeah. So I was updated. So with the current wind and the launch angle, we will probably reach 25,000 feet. Since due to the wind, we need to essentially tilt the launch rail in such a way that we get a somewhat of a safe launch, such that it doesn't get swept away by the wind backwards towards the spectators. And due to that, the launch angle is adjusted, and well, if you can imagine, if you set it up more ballistic, that was a beautifully slow rocket.
Easy to track.
That was beautiful. Okay, hope you enjoyed that one, as I did. And in any case, so we will have afterwards the second stage ignite, taking us to about 25,000 feet. Yeah, I left off at the launch angle. So the launch angle has to be adjusted to 6 degrees, and if you can imagine, the more you adjust it, so the more launch angle you get, the less altitude and more distance you get out of the rocket. So that is the way it currently looks like. And also the wind tilts the rocket against its direction, so in the opposite direction of the wind. So even if we launch like this, we might have a wind tilt us back into the direction. Since the wind is blowing right from my back right now, the rocket might actually tilt towards upwards towards us, essentially. Yeah, so that is how it will currently, with this kind of wind, look. We are looking at a yellow flag, I think, slowly. I will confirm that soon, after the launches are done. Hope you are enjoying the show. I mean, rockets launching left and right here.
got more gases.
We have more tape.
Helps you. Tape I also have.
Yeah. Ja. Ist das okay?
Wir können vielleicht irgendwie was zwischenstecken, einen Stift oder so.
Ja.
The wind tilts it forward.
Something like this?
Hast du AKS Setup?
Ja, neben dir.
Okay.
Cannot figure it out.
Is second stage already on the trail? No. Okay. Und du sollst das Ding so einstellen, dass es weiter
We have food. Yeah.
What the heck? Okay, so a rocket just did quite a few Tokyo drifts. In any case, the wind, to answer Lawrence's question, the wind is pretty strong out here. Currently, I think we are expecting, 7 meters a second or something like that during launch. it will keep on increasing, sadly. So the later we launch, the worse. I still haven't gotten any updates from the pad. I will let you know as soon as I have any. And yeah, so far enjoy the show. Yeah. Integrating the cooling system. Okay, nice. We might have a problem. I cannot figure out the RTMS, RTP, RTM, whatever the fuck that is.
No, no rocket trail.
Maybe I didn't have that hit. I don't know.
I tracked something I can't see. Try to. Benji, can you get ECI running? Or like embedded?
Let's see. Do you have any Wi-Fi Ethernet cable?
Yeah, in the box.
Like,
More.
okay.
Okay, so the files on the setup time.
Yeah, let's try not to have it in the sun. That is prone to overheating from yesterday. Is it working okay, the payload now?
Yeah.
Good.
No
Good,
need to
good,
be
good.
very happy. Wishing for the best.
Yeah.
And we have fresh algae. Oh,
Oh yeah.
So that's why you're gonna see it here.
Bong.
it just went down near the tent.
Now you can also record. Like clean here. Yeah.
embedded. I can't figure it out.
And I'm gonna rearm D4 one more time. Oklahoma State, I'm gonna give you the hardest button push I've got in me here. We'll try it again in 5, 4,
Yeah.
3, 2, 1. Go on, hit. Oh, guys, I put another $5 bill in the slot up here and it still won't go. Sorry.
Mission control calling for Paul. For like the final flight ready command, what should I use as time? Just when it starts talking about our rocket in general? Okay.
Alright, that should be it at this time for the solid salvo. The pad managers are coming back over to the students and we'll start getting solid salvo reset.
Is there anything that I should film right now?
I don't know. If you want the launches, most probably. If
You want to try?
I mean, if you want to see the setup,
I think we're already good. Like we're doing a really good job.
yeah.
Really hard.
I mean, you can just take pictures and film everything, you know. Worst case it is, we don't use it, you know.
Yeah. And but if he can save the battery for the actual launch, I guess we would prefer that.
Ah, okay, we have battery limitations.
Sadly, on that camera, yes.
Only one and that battery is
cannot-
crap.
Yeah.
Okay.
Let me know once the battery is getting low.
3 out of 10.
3 out of 4 still? Okay, that's good.
Good news or bad news?
That's good.
Hopefully good news, because they're going to check it out and then is it good?
Probably. I don't know. Wenn es nicht piepen, dann sie auch nur ein Kabel da. Vielleicht dieses Ding. Dann nehme ich schon fertig.
Whoa.
Careful, careful.
Gonna need some camping chairs here.
Ich glaube, wir fahren einfach mal mit den Getränken und schauen, dass jeder auch was trinkt.
This is mission control. Hello, this is Aaron.
Der Crew-Wave hat schon die richtige Konfiguration, die wir besprochen haben.
Bitte sicherheitshalber nochmals aufladen.
Das ist nicht meine Frage gewesen. Hat der Crew-Wave die richtige Konfiguration?
Ich bin mir nicht sicher.
Haben wir hier den Mülleimer? Schon. Benji,
Yes?
did you set up a trash bin?
No, not yet. Do we have trash?
Yes, trash? Yes, trash.
Yeah, no, but trash can. No, a trash
Bag.
sack.
Bag. If you all eat faster than we. Good point.
Benji,
Yeah?
put the volume.
What? Oh yeah. I'm aware of that. I do not want to like, since we are so close to the mission control.
Yeah, still be 10 and set it.
Okay.
Was hat er mich gefragt? Ich weiß es nicht.
Gar nicht.
So,
Dann hat er gesagt, copy that.
Ja, geht's nochmal.
Was hat er gesagt?
hello you guys.
Ach so.
Sorry for the audio. Sometimes I'm talking to other guys because I'm currently trying to set up something on the computer for the live video challenge. As we are currently trying to send the live live videos to the officials and the stream of the Spaceport America Cup. However, as it stands, there's still a lot of work to do. So that is why I'm from time to time talking on camera. I will try to disable that actually for now, such that you just can enjoy the launching of the rockets and do not need to watch me looking at the computer. Sorry about that one.
Oh, die sollen geflasht sein, ja. Ich kann mich an das jetzt mal, als wir aufgemacht haben, habe ich kurz beide hergenommen, einmal den angeflasht und den anderen geflasht.
Sorry, Kiara. Could you?
Of course. Yeah.
Überlege ich mir mal, ob ich die HS-Dinger
Trying this on the spot is kind of harsh.
Überprüft sicherheitshalber nochmal die Einstellungen in der App.
Das letzte Mal, als du konfiguriert hast, war das in der Anwesenheit von
Ja.
She can't hear any
Okay.
authentic.
Okay.
Ich glaube, das ist eigentlich eh euers. Ja, aber irgendwo müsst ihr noch ein besseres Tape geben.
So, du willst das Tape?
Can you see?
Optimal ist eigentlich nicht das, sondern im Optimalfall was anderes.
Wir haben jetzt bei uns kein Tape hier. Das ist
Ja, aber hier
euers.
war vorher noch anderes Tape. Oh nee, nevermind. Ja, dann das.
Ist nicht unseres, glaube
Ich
ich.
weiß, es ist unseres.
Ah, okay, ja.
Ja.
Okay.
Aber.
Was soll ich dir geben?
Ja,
Benji,
aber.
may I walk through?
Yeah.
Ja,
Go ahead.
Yes,
But if you do
Stargate.
it quickly, no problem.
Stargate Payload.
Come again, please.
Einmal die Antenne.
Do you copy?
Hätte dich gefragt, wir müssen ja irgendwie nicht hier.
Copy.
Kann man es noch reißen?
Das letzte Mal, als der Flightcomputer konfiguriert wurde, war das in Anwesenheit von Dennis? Frage.
Ja. Dennis anwesend, ja.
Okay, so as you can see on the and also on, of course, engines. So yeah, the moment that flag turns red, we are essentially ready to go. Hard to say what how long that might take for now, but yeah, we are very close, very close to getting this rocket into the air. So stay tuned. We will hopefully be able to witness the launch soon. Two out of four battery. Okay. It's been running for quite long now. think it's holding, then just let it go. I mean.
Benji, would it help you if you got one more outlet?
Nah, not really. Unless it would help you.
What?
Oh, we are currently working good. There is somebody named Aitor Guerrero Hernandez on the stream.
They're lowering the.
There
yellow
is somebody called Aitor Guerrero Hernandez on the stream.
What is he saying?
Spanish flags. Come say hi.
Yeah, he's my brother.
Okay, wait. Let me answer first the question, and then I'll get to it. Okay. So, as to the question of how hot it is, currently it's a very cool 25 degrees. Today is actually a relatively cold day where the temperature should not exceed 32 degrees Celsius. And to Aitor, I have a guest for you to the stream. Go ahead.
¿Qué pasa, picha? Aquí estamos. We're gonna launch now. Thank you guys for being here. I really appreciate it. I know you guys are super anxious to see this launch as much as we are. So thank you very much for the support from everybody, and I hope you like the launch. Viva España! Viva Alemania! Let's go WARR! Let's go West!
Okay, hopefully hopefully you didn't say any swear words. I could not quite understand everything. I know you. Doesn't matter. Okay, so continuing with updates from the pad. We are currently I'm not sure if the payload cooling is already set up. I didn't hear that update. Is it?
If it's set up, we don't know, but it's worked on during integration.
Okay. Okay. I will try to get more updates from the pad right now and see how it goes. Let's see this rocket launch. Yeah, we are very, very close. So, go West. And Angel Guerrero Castells?
My dad. My whole family is gonna be there.
Okay. Oh, that's so sweet.
What is he saying?
Fuck you.
What a shit. Spanish flags? Oh, that's
Oh,
Vicente.
that's
That's
Vicente.
Vicente.
Come on, fly high.
Fly high, nice. Angelica, she's my girlfriend.
Angelica.
Yeah. All the crew is here. Concepcion Catalá is my stepmom. Ichi is my friend. So like two people again, please.
Yes, hello. But the link I sent must be public. I sent it to the.
It's working. It's working.
It's working according to the stream. The stream is public. The latest link is in the launch crew WhatsApp. Okay, I will check it, but it should be the correct link. They need the embedded one. So should we directly stream into their? Can I get in touch? Can I go to the LC? Can I actually talk to them?
Probably. We could
You can go if you want to.
We have like another walkie-talkie, don't we?
We have, yeah.
So we can send someone with a walkie-talkie there, and Benji can deal with it here. It's probably smarter.
Okay. Does anybody know what it is? What?
SAM car, the mission control. No.
What do we need from there?
Lawrence, you know where the mission control is. Can you tell someone?
I want to set up the live streaming with the embedded stuff or something.
No, the official.
So we can stream from the rocket.
Okay, so they embedded the old one.
I don't really know what that talks about.
Who's
Man kann bestimmt auch welche Fragen finden und dann fragen, ob es ist.
Okay, so and for them it works. For them it works.
Ein bisschen Sorge, dass das, was gerade nicht so gut funktioniert, ist, dass das Cooling-System
So far we haven't
es
received
ist so
FPS.
wenig, dass die flackern, das heißt, die müssen alles drücken, die ganzen Kilometer. Das könnte Zeit dauern.
Yes, we are ready for FPS.
Und
Which stage?
hat er jetzt die blauen Dinger umgebaut? Weil hat Jonah noch irgendwas gesagt von wegen, er will diese Foam-Dinger benutzen, die wir hatten. Also diese Foam-Strips. Beides. Na gut, das beansprucht Zeit.
I think I can see the rubber on the back.
Welche von den drei ist das?
Die mittlere. Du siehst das
I will
gelbe,
try. I will try my best. I will
Kein
see what I can do.
Nimm dir die nie oder hast du eine super Suche?
Lower stage.
Okay,
Just to confirm,
anybody who is
we are
not
testing
working on
lower
EGSC,
stage
I need your
right?
help. Please search up how we can embed a YouTube live stream using an RTMP system. That is like a protocol which apparently if I produce a link, they should be able to view that link through their launch stream.
So streaming to YouTube using custom RTMP.
You want to stream to YouTube using RTMP and then that's a link.
Go to dashboard venue session, add a session, create new session, hover over existing. Under RTMP settings, I'll enable streaming checkmark. Okay.
But your encoder setting has to be RTMP.
We haven't received the signal so far.
I think I can
Originals coming out.
I give it 50-50 right now. I found something that should work, but yeah. Okay, understood. Okay, so let's go to OBS. Dashboard venue sessions. Where's dashboard? There's no such thing as dashboard. Go to event dashboard.
Noise when you're talking.
Give me a second.
FPS boosted.
Yeah.
Okay, we're listening.
The problem is that do they need to the encoding like never done this.
I know that I'm asking a lot.
Yeah, I know it's important. I will keep on doing. Yeah, it should be this URL and the stream is public.
Lawrence?
Yeah, it should be this URL.
Er kann alles verstehen, was du sagst.
Ja, jetzt geht's auch besser.
The URL has to be public as well.
Yes.
Aufzeichnen. Live racks. Live chat. The setup is. Yeah, the streaming software. No. This is streaming. No. Lizenz. Standard YouTube license.
Now embedding, that's right. That's correct. That's good. All of that makes sense.
Yeah, we cannot find a setting which sets up the link to be public. I mean, we do have the stream key.
No, don't share that. Don't share that.
That is not to be shared. Okay.
Alex says it could be difficult because our camera is so low compared to because there's stuff in the way.
Okay, let me check. Streaming from OBS to OBS is free open source guide. Important. Go to event dashboard venue sessions. Test event. Oh. They think we are. Wait.
Red flag, guys, red flag.
Red flag. Red flag?
Red flag.
Yes. Red flag. Is APRS working?
No.
You want to raise the whole tent?
Or maybe take 6 an hour.
Ludwig, in such a short time, I don't think I'll make it now.
Is yours better?
The one that I sent is the newest one, per my understanding, but I'll send you a new one. Yeah, this should be the correct link. I'm sorry, Ludwig. I'm very terribly sorry.
Can they not screen share their screen with our live stream?
No, this would have taken a day of figuring out.
What's the RTMP?
I'm in the YouTube settings. Apparently, it should be a server, like it should be through the streaming service.
Go back
Set
to
up. Tab with.
Copy next to stream URL. Right? Is that not what you need?
Yeah, that is what we need. But for some reason, it is.
URL, I can try here.
No, the problem is that we cannot figure out which YouTube setting does the makes the URL open. Like that is, and I'm not even sure if that would work.
This is public, like YouTube is public.
Yeah, I know.
Everything there is set to public. Maybe check in OBS.
Yeah, this is the correct stream link. This is the most up-to-date stream link.
But I'm not sure
The URL remains the same for some reason. I cannot understand why. YouTube Amsterdam.
Yeah, but it needs to connect to the laptop, you know. This cable has a certain length.
Can you like the center?
Take both.
No,
There's the second one above you. On the inside. On the inside.
Ah,
Above your
but
head
that is
triangle. Yeah, this one and
this URL only works for the streaming encoder
no.
that we have here.
That's what they want, probably.
But
That RTMPS colon / that's
Might just
what
be
they want.
that our setup is shit because this hardware is like cheap.
Wir haben keine Signale gefällt, oder?
No.
We never received a signal from any of the stages. We're trying to get the antennas higher now and then we can retry.
okay, to give you a short update, we are currently on red flag status, which means that we are clearing the pad. We will try to stream live video from the cameras on board on the rocket. I will let you know how that goes very soon. Yeah, we are a few minutes before launch. The moment we start the countdown, I'll let you know. Stream setup, yes.
We put the IPS antennas a bit higher now. No attention.
Yes, so we have the RTMPS link,
Okay, then.
but it's the same as the one before. Cannot find the difference.
There are short YouTube tutorials on the topic.
We cannot hear.
Okay, I will try to watch one.
Does it make sense to take them now or take them later?
Just go to the setup and on YouTube and look if you find anything.
I don't know
Go
what.
to the OBS setup and look if you can find anything because probably OBS uses that exact link as well.
No. OBS uses a stream key. OBS uses a standard YouTube link for going live, and then a stream key. That is what I embed in OBS in order to connect to the channel, like connect to the stream.
Okay. Just look for another link, otherwise we'll call it a day. It's not our fault that they cannot provide us what they told us to provide.
Yeah, I will. Yeah. Okay. Well, anyway. Thanks a lot for the rundown. Good luck on the pad. I will see you soon.
Can you put your PC more here? I'll just try to put as high as I can. Yeah, to see if that makes a difference.
Yeah.
Rocket is up right, and the lower stage igniter is not yet installed.
Okay.
Dennis has received both signals at the pad with his receiver.
See you soon.
It could be that either we're far away
T-15.
or that his receiver is just better.
1-5, understood. Okay.
So either we get it working with our setup now, or we have to get Dennis' receiver here.
Okay, we can keep on trying.
Yeah. Until they make that decision, we'll keep on trying.
Guys, you're literally right in front of the camera.
Come on.
It's fine.
No, now you're not. But beforehand, I just now noticed when I watched the live stream. Okay, doesn't matter. Doesn't matter. Less stress. More enjoying the live stream.
Should I move it around?
No.
So, sorry for the previous. So we are trying to embed the live stream into the SAC live stream, such that we would be eligible for the live video challenge. However, this looks as though it will not be possible. So, yeah. Currently, I don't know if you could hear the phone call. Yeah, sorry for leaving it open throughout that. We are currently approximately T-15 away from launch, according to Ludwig, which encompasses inserting the lower stage igniter and getting an APRS fix on the lower stage. So that is the only last two things that we need to do before we actually launch. So starting the countdown now.
We got the pickup here, we can go a little higher.
I don't know what Alex is talking to. Was ist los?
Range Safety ist not happy damit, dass wir es hier nicht empfangen können.
Ja.
Mehr kann ich nicht sagen.
Ja,
Seitdem
okay.
haben sie nicht mehr gesprochen.
Dann probieren wir es jetzt nochmal höher zu stellen. Oder dann soll Dennis halt mit seinem Receiver hierher kommen. Und dann sind wir halt jetzt Mission Control und nehmen seinen Receiver. Okay? Guck mal hier. Ich sag dir, du sollst jetzt nochmal probieren.
Could you give me the link for the UX UI?
Yeah, you have to enter an IP address.
What?
You have to enter an IP address.
I-
It's 192. Arming
192.
Okay.
Dot 168.
168 dot.
Dot 1. Dot
You move this,
99.
and I'll bring person start here, and then we can go with everything. Okay. Why do you think person start? Why did it go higher?
Maybe because it's preferring the
The PC is there.
Wi-Fi over the
Yeah.
connection.
The cable then on you know. I know, but you move the PC.
Right.
Well, yeah, there's a lot of range.
Please don't lay down the antenna close to any PC.
Yeah.
Just,
Where you want it?
I mean, optimally where you
Okay.
got it from.
Alright. I can put them back.
Hast du noch irgendwas einstellen gefunden? Ansonsten gehen wir jetzt.
Ich habe hier,
Gerade zwei sehr.
das heißt, schwache Pakete auf einer etwas leicht verresteten Frequenz gesehen. Jetzt die Frage, ob die von uns sind oder von jemand anders. I don't know.
Aber rede bitte mit denen am Pad, weil Silence ist das Schlimmste. Das
Ja. Ich versuche gerade erstmal wieder rauszufinden, ob ich jetzt überhaupt was sehe oder ob das nur einmal war. Wenn es nur einmal war, dann war es bestimmt nicht von uns.
Wen brauchst du dafür?
Kommt auf an, das Signal nochmal kommt.
Ja, da geht.
Mein Gott, ist aber nicht.
Probieren wir es nochmal mit denen zu hören.
Können wir das Auto bitte woanders hinstellen? Können wir das Auto bitte woanders hinstellen?
Auto woanders hin.
Yeah. No, it's a big metal box in front of all of our antenna stuff. No. No. That won't work because it has to attach to the laptop.
I know, but you moved the laptop with me.
Hold on, I'm trying.
Maybe we can try, I guess, but can you move it over a bit more? Yeah, can you move it over anyways, because like we can't receive the live telemetry from our WARR.
Hast du ein längeres Mini-USB-Kabel? Oder generell ein längeres USB-Kabel?
So, away, or?
No,
It's
a little bit more
side.
to the side then.
This? I cannot get to the.
Eine USB-Verlängerung. Bei uns? Okay, then sorry Leo, but then we have to unmount it again and we'll try to see if I can get higher or
Can you get this higher and point it at the launch site?
Okay. And somebody has to run that. What is point? Point what?
Towards the
Yeah,
This one.
like this?
Yeah. Sie haben uns noch was gesagt. Ja, da.
Can you push the
Kannst du irgendwo
black
hingehen
button
und
on
den
top
Fang
of
schauen?
the board?
This one?
Yeah.
Just what?
Yeah.
Das Ding ist aus, glaube ich.
Was?
Then rotate it.
We now have it higher and of course that's lesser. Can you please try to have no feedback in your position? We're barely understandable.
Ist das Ding aus jetzt?
Das ist an, aber ich hab's runtergestellt, also.
Alright, we put the antenna higher. We can retry your warp telemetry.
Hannibal, can you take the antennas, go to the car, I'll get the laptop and come around.
1 out of 4.
No, no, the ones that are glued on top of the pen. Look at. Oh, this one? No.
Yeah.
Inside.
Yeah, this
Oh, so this yeah. Okay.
One out of 4 battery. I will try to get it.
No.
one probably.
Still not getting any signal.
It's not detecting the Ethernet at all.
Alex, wärst du für APS bereit? Ja? Was ist dir lieber? This is mission control. We haven't received WARR telemetry, even though the antenna is very high. Our APS antennas are even higher now, so we can try to tell us which ones are there.
Und ist schon in Antennen verbunden, ne? Nicht mit Termination Resistance.
We are now clearing the pad. Our launch is on hold. On hold.
Alright. So the others are gonna launch.
Okay, so our launch is currently on hold as there is another rocket prepared, and yeah, we'll try to catch it in flight. So we will resume operations once we get the green flag again, or at least the yellow flag. Yeah, so I'll get back to you right after we launch this rocket. I'll also try to comment on how the flight is going. So yeah, first this rocket, then ours. So, to recap, so there will be a launch before us. That is the red flag currently. We have cleared the pad. That is why the timer is on hold. So, currently we are sadly not receiving the signal from the rocket. We will need to fix that before we launch, as the GPS tracking and APRS tracking are a must. Once that is done, we are clear to launch. So that is after this rocket, we'll go to the pad and get everything ready to try and attempt a launch, hopefully in the coming next hour. It is essentially a few minutes of setup on the pad itself, if everything goes right, then we will be able to provide you with some cool live footage from the launch. So stay tuned. I'll get back to you once we start launching this rocket. So that is from another team, not from ours. And afterwards, we are going to prepare everything for our launch. Hopefully happening within the next hour. It's hard to predict because usually it takes about half an hour to clear the launch trail, because usually they are slotted to launch one after the other, which means that usually it takes quite a while until we get the green flag again. So that is what is happening currently. I will inform you once something new comes up or when the launch starts.
Ja, ich guck, ob ich eine habe.
What's the fucking link?
Wann habt ihr den Cats angeschlossen?
That what is in the...
Okay, weil ich habe noch kein GPS
They
dabei.
say it's over already.
Oh, it isn't.
I put up a terminal there, so you can move your...
I just have it connected right here. Let me check. Do I have the old one there?
Let's go.
Give me a second. I need to make a persistent link.
Yes.
Okay. Okay, this is the newest one. I'm sorry. I didn't realize that I didn't send it to blog.
Power is getting a power bank, so
Oh, fuck. Solving issues I'm not built to solve.
Powerbank. Hier ist auf dem Video.
Okay, got it. So apparently we're gonna test one.
Ja.
Antennen für WARR oben auf die Leiter drauf.
Ja, aber lass mal auf der anderen Seite erst versuchen. Weil wir können den Handyreceiver mal anmachen, ohne dass er mit dem Sky verbunden ist, und gucken, ob er blinkt. Und wenn er blinkt, können wir wieder gucken, ob wir in der Todstelle das Ding das hat Dennis ja gerade schon gemeint. Dann würde ich gerne die Leiter bitte nicht direkt da aufstellen, wo wir gerade keine GPS haben.
Naja, die Leiter ist halt 4 Meter.
Powerbank.
Ja, aber auf dem Auto stehen ist ja irgendwie...
Jetzt, wir testen es mal mit der Leiter.
Gut, dann testen wir es mit Leiter jetzt.
Tritt so unten raus, auf die Leiter. Ja, danke. Bis dann. Ciao.
Du hast doch noch nicht gesendet, oder?
Nein.
Dann sende es jetzt bitte.
mal, gehen wir mal auf die andere Seite, dann probier's da. Benji, why are you not in the live stream? There should be someone in the live stream at all times.
Okay.
Bro, that is your main job, not standing around and watching.
I just updated them.
Yeah,
but
but you should be telling them stories, or I don't care, but
okay, yeah.
it cannot show just the end of the tent.
Yeah.
They have to hear something, they have to know something. You are the one in the live stream. If I request something else, you forward that to someone else.
Okay.
But you are maintaining the live stream.
Okay,
And there has
understood.
to be someone in the live stream any time.
Okay,
Only if you have to take a shit, you can go out anywhere.
understood.
Thank you.
Okay, so I don't know if you saw that, but we are currently trying to get an APRS track from the using the ladder. We think that the Starlink that is used for the stream is currently disrupting the signal, which is actually very, very possible. So we will try to get everything working with the live stream going on. If all fails, we will try to use my phone as the backup. So with regards to what has been happening in the past few hours, so to give a rundown of how every day here looks. So we come to here at around 5 a.m. This time around, sadly, I don't know if you've seen the Instagram post. However, we've had a dust storm going on here, and that dust storm essentially, literally destroyed the setup area. So we had some fallen over tents, broken down tents at the setup area, which is why the competition was literally put on hold in the morning for them to try and set everything up. Unfortunately, this meant for us that we were only able to access the site at 7 a.m. With a delay. That is why we are currently here relatively late, and we are trying to set everything up. We wanted to originally launch at 7 a.m. but this didn't work out, as we are still here. So as for a recap of the past few days, since if you do not follow us on Instagram, it's kind of hard to keep track. We have come here on Wednesday last week in the morning to Truth or Consequences, which is a town relatively close to us, about 45 minutes travel from Spaceport. We have set everything up for integration, integrated both stages by Friday, and afterwards we proceeded with electronic setup. The electronic setup was finished by Sunday, with everything tested and running. Afterwards we attended the convention. The convention was held for 2 days in total. On the first day, on Monday, we passed the safety reviews and everything that is required for us to actually get to Spaceport. And afterwards we had another safety review here directly on site. That was on Wednesday, yesterday, which we passed. But beforehand, during Tuesday, what has been happening is mostly us going around in the convention, asking other teams, and actually Anibal was holding a presentation that represented Whisper and presented the team as a whole. So if everything goes right currently, we should be able to launch soon. So as for the recap of what has been happening on the pad, that is, we have turned on the computer, so the primary flight computer in the second stage, However, we are not receiving live signal from it. That is why you see us running around with the ladder. And we seem to be currently troubleshooting that issue. So, with regards to, so currently there has been a discussion of us getting a Yagi antenna, such that we can actually catch the signal. So the signal is a 144 megahertz radio signal, and yeah, we are, since a lot of teams are around here, we might have quite a bit of disruption from other sources.
But either way, we are go for launch at this point.
We are go for launch.
Yes. We might not have live video, we might not have warp, we might not have anything, but we have GPS tracking for both stages.
Okay.
So we could launch right now.
Okay.
But we are trying to improve our tracking and fix the live video.
Okay, understood. So, as far as the electronics team is concerned, we are go for launch. We have only GPS tracks currently for both stages, which is the only thing that the competition requires. What the APRS is required for is tracking down the rocket after it lands, which would help us recover it in case we do not see it return safely to the ground and do not have line of sight. So, as said before, if you weren't here on the stream, we are a two-stage rocket, so we have two stages to track. When they separate, the sustainer, the second stage boosts off, goes off into around 25,000 feet in altitude, which is around 8 kilometers, and then proceeds to deploy at apogee the drogue, and when it descends, deploys the main parachute. When the main parachute deploys, we hope to have a visual on the rocket, but however, if we do not, then that is where the APRS tracking comes into play, where we can have a directional, essentially directional positioning system.
No, it's GPS. It sends GPS packets.
So it sends GPS packets. I'm being corrected continuously. Such that we can find it within the given such that we can find the rocket actually. Yeah. So as far as we are concerned, we are go. I'm not sure if we are going to try and troubleshoot it right now. If we cannot find anybody with a Yagi antenna, we are going to go to the pad after the flag turns green, and we are going to prepare everything for launch and launch immediately afterwards. Yeah. So sadly, it looks like if we cannot receive telemetry and our antennas, we sadly won't have live video from the rocket. Yeah, unfortunately, that is probably what it looks like will most probably happen. Yeah, I will try to track the rocket with the camera to the best of my abilities. In case everything works, then we should be able to. So in case at least the APRS stuff works, we should be able to recover the rocket safely, even in case of a ballistic recovery. Yeah. Okay. So some other stuff. So since we are still waiting for launch of the other rocket, let me give you a rundown of what we have in our rocket, such that it is kind of clear whenever I talk about recovery, electronics, or whatever part of the rocket, such that you know what is being said. And yeah, so we have two stages, as already said. The upper stage is from the top down. We have the nose cone, which inside of it has two parachutes, essentially the upper stage recovery system. It has a drogue chute, which is a smaller parachute. This parachute is designed to slow down the rocket after apogee, and give us the ability to then afterwards deploy the main parachute. Because if we deployed the main parachute directly at apogee, what is most probably going to happen is that the main parachute would tear apart, and unfortunately that would mean that we couldn't recover properly. Yeah, so after this segment comes the payload segment. The payload segment is a experiment which tries to investigate bioluminescent algae. The payload yesterday unfortunately had a leak, but our payload team was able to repair that, and we are currently actually actively cooling the payload on the pad such that the algae survive. Yeah, so inside of the payload there are photon sensors, cameras, microscopes. Not really. Optical power sensors. Okay, and those provide visual on the algae, such that we can then evaluate the behavior of this algae when it reaches the zero gravity coast phase or low gravity coast phase, once we are at the burnout of the second stage. Afterwards comes our electronic segment, which is essentially our primary flight computer. The primary flight computer consists of what it can do is telemetry. It should be able to send it live. Currently, we cannot get this telemetry to work, unfortunately. If everything goes correctly, it will save the telemetry, hopefully, and so we can view it afterwards and evaluate our flight, and afterwards essentially provide some more details on the flight. So there will most definitely be a post about that, either on Instagram or on LinkedIn, probably both. With respect, it's quite windy right now. We are trying to stabilize the tent. So the other things that it does, actually, it was developed originally for our biliquid project Nixus. This computer has high currents or high power switching capability, because it needs to switch valves that power or that control the flow of liquid oxygen and ethanol through our biliquid rocket, and of course high pressure. Yeah, we just had a launch. I wasn't aware of that. This burned for quite a long time. This was quite a long burn. So yeah, back to the electronic segment. It was a hybrid. Oh, so this was the hybrid pad. Oh, that's why it was from a different direction. Okay, that makes sense. Yeah, and so with regards to the primary flight computer, back to the primary flight computer. So it should be able to switch the valves inside of our biliquid project, and if possible, well, it is actually for us, it is mostly just switching the recovery so it just sends current to images in the recovery systems and the igniter of the second stage. There is a second flight computer, or a secondary flight computer, that is commercial off-the-shelf computer. It is also capable of triggering recovery in case our primary flight computer fails, and that would essentially mean that we would be reliant on a COTS hardware to trigger everything. However, this is what most of the teams actually here use. So most of the time it works flawlessly. And yeah, this is, as said, again, only if something goes wrong with the primary flight computer. Afterwards, after the electronics segment, comes the fin section. There is not much to say about that. It provides stability for the rocket, which is, yeah, especially important in this kind of gusty, windy conditions. Afterwards, so below the fin section is the engine, which is just screwed in and actually held by a screw inside of the rocket. We call this the gravity screw. We had a problem with a similar system. Was this also a hybrid?
No. That's red solid.
That's red solid?
30K.
Wow. Yeah, so we just had another launch. This was a self-developed solid. Yeah, unfortunately the camera went out, I just noticed. Oh, that is so unfortunate. I'm so sorry. I will change the battery quickly in the camera, and we'll continue live from the live video from the pad. Actually, what should happen now is that the other solid pads will launch. Afterwards, we should get a green flag, if everything goes right, we will get the go to the pad and prepare everything.
Und dann haben wir bei denen noch so eine Riesenantenne.
Okay, so currently troubleshooting the issues with the camera. However, I'll get it running very soon. Yeah, our guys are currently trying to get a track with antenna that they borrowed from another team. I will let you know how that goes. Yeah. However, we do have GPS. We should be all good with regards to that. So if everything goes well, the next launch window is ours.
You muted? Muted? Benji? Yeah. Muted. Good. In such conditions like these, our rocket wouldn't have such a problem because it's so heavy and so big, right? Like it would be quite hard to move it. Wetter kein Problem. Wetter kein Problem, sagtest du? Wetter, genau, dann werden wir es nicht brauchen.
Oh God. Oh God. Okay, good. Yeah, good. Aaron?
Yeah.
Do you know where you put the camera cover? Like the lens cover? If we are not recording, we should probably put that on, such that we do not have a problem afterwards. Okay everyone, camera has been officially troubleshooted. So currently we have guys on our pad. They are trying to get an APRS lock onto the rocket. As said, APRS is the positioning system which just repetitively sends its GPS location such that we can track down the rocket after it has been recovered, either ballistically or with parachutes. Yeah, and since we are flying to 30,000 feet and with this kind of wind, it is very possible that we will fly quite the distance. So we would, if we didn't have this APRS track, we would need to search the desert for the rocket, which would kind of be a long endeavor. Yeah. So back to the rocket, because yeah. So I stopped explaining, I think, after I started mentioning the gravity assembly. So back to the upper stage. The motor is inserted from the bottom, and as it is inserted, we need to catch a screw that is essentially riveted down in one of the segments of the rocket. And once we insert the motor and catch the screw, we screw the motor in such that it holds during recovery. And afterwards we try to so what we then try to do is tighten it such that it sits flush with the upper stage bow tail. Our bow tail is both a bow tail, which is essentially a tapering in the back of the rocket, and aerodynamic tapering in the back of the rocket, and also holds all of the loads that the motor is producing. So when we fire the motor, this is the main point of contact to the motor, not the screw up top. So yeah, now to the bow tail of the rocket. This actually serves one more additional function, which is the staging mechanism. It is inserted onto a counterpart in the lower stage, which is a 5-axis milled part, and we insert it and have essentially then a passive mechanism, which essentially means when the lower stage burns out, the drag should be enough to separate both stages away from each other. Afterwards, the second stage fires. Continuing from the staging mechanism, this is actually the part that we are currently having a problem with. On there is the APRS trackers. Like at that point in the rocket, it is like this high of a segment, and it has those APRS trackers, and also includes the umbilical connection to the rocket, which enables us to communicate with the primary flight computer, even though we actually do not have both rockets as a single piece. Continuing down is the electronic segment of the booster. Those are two COTS computers, essentially assembled together with batteries, such that there's two of them to ensure that we are safe, and in case one of them fails, we can still recover with the other one, and vice versa. With regard to the recovery, actually just below these two COTS computers is the recovery segment of the booster. It is a sideways system, which means that as we are flying up, the booster will, or as we are nearing apogee, the booster will cut ropes that are holding the hatch on the rocket. So it has a hatch that encloses the parachutes, and the packing pressure of the parachutes, we actually have to push the hatch down quite significantly in order to get it in. The packing pressure is enough to push the hatch out, and then essentially aerodynamic drag takes over. The hatch then gets pushed out, takes the drogue out of the rocket with it, and ensures that we deploy the drogue at apogee. Afterwards, we fly on the drogue, also on the booster stage, and with that, we then trigger at 300 meters the main parachute of the rocket. So, continuing a bit more down, we have our motor. This motor is quite a big one. So what I should first do is explain the classes of the motors that we are flying with. Motor classes are designated alphabetically, and the higher the letter, the more total impulse it produces. So total impulse essentially means that we have that it either produces more thrust than a engine with a lower total impulse, or it produces the same thrust for a longer amount of time. Our engine in the lower stage is as an N5800. The designation of the number designation essentially designates the thrust, and we produce 8 kilonewtons of thrust of the rail, accelerating us to essentially Mach 0.8 in about 3 seconds, and then afterwards we attempt to separate the both stages. So after the 3 seconds, both stages separate, and we are getting the second stage ignited. The second stage ignition, is I would say the hardest part of the flight. as we have no way to ensure, or in case the ignition fails, replace the igniter and try again. It needs to work. Otherwise the flight is essentially over. So yeah, on the upper stage, the engine is an M class, so it has a lower total impulse than our lower stage engine. However, what it does is that it has a longer burn, accelerating us all the way to Mach 1.4, with which we will coast to those 25,000 feet mentioned earlier. Yeah. Since the rocket is two-stage, I think I already mentioned this, but we are getting a separate pad, and all of the competition essentially waits for us until we are done with, essentially is on pause until we launch, and afterwards continues if there is a launch window. Yeah. There is one more thing on our rocket below the booster motor. That is the titanium 3D printed motor mount. This is the thing that transfers those 8 kilonewtons of force through the entirety of the rocket, or ensures that it is transferred onto the rest of the rocket. This 3D printed part has been done with a topologically optimized design. So essentially, we run it through a simulation, and when the simulation is done, we find the places in the motor mount which are experiencing the least amount of stress, and remove them. And you do that over and over again until you get a part which has everywhere around the same loading and around the same safety factor. So we remove as much material as is humanly possible from that part to reach a certain safety factor. The safety factor on that part is 2, so theoretically it could hold 16 kilonewtons of force. However, to make that kind of analysis and essentially, if you want to have a safety factor of 1, you would need to be very, very, very sure that all of the simulations that you've done and all of the calculations that you've done are very accurate, which is not always possible for a student rocketry team. However, we are very happy with the safety factor of 1 because the part already weighs just 200 grams and essentially is as optimized as we would feel comfortable with. This part was actually post-processed in our titanium. To give us some context, titanium post-processing is quite the complicated process. It was actually post-processed at one of our partners' workshop makerspace. It was post-processed by Andrea Cataldi, who is our homegrown manufacturing wizard, and essentially he is responsible for that being post-processed correctly. What needed to be post-processed after 3D printing? So you have to imagine that as the motor mount got 3D printed, especially on the outside surface, not everywhere. It isn't smooth. There is like a grainy kind of texture to it. So what we need to do is make sure that due to the mounting of the engine, we have a fitting surface on the inside, which ensures that we essentially can fit the motor casing into the rocket, and afterwards we essentially then again insert the engine into the rocket and screw it to a gravity plate screw, which is again up top below the electronics section, below the recovery section of the booster. Actually, a lot of the motor mounting post-processing was done at the local workshop Makerspace. We are very thankful for their help in all of our endeavors. It is actually quite amazing that we get access to machines which we could never afford on our own. For instance, quite a lot of the components get manufactured on the 3-axis CNC, which just allows us to get the most out of our components. A good example for this is, for instance, the nose cone of the upper stage. There is a plate which essentially holds the parachutes after they deploy. This plate has to be three axis milled because it has some quite complex geometries on the top, which would be very hard to get through a normal mill. This concrete part is essentially responsible for mounting all of the recovery, and this is where we mount our CO2 cartridges, or the CO2 cartridge system that triggers the CO2 cartridges, and also where we on top of this is where we have our GPS antennas for the upper stage. The upper stage also has quite a bit of carbon fiber inside of it, as we essentially used a technique of using hand lamination as the initial component. Hand lamination, for those who do not know, is a technique where you take a carbon fiber which has been already impregnated with epoxy. You lay it over the top of any shape you desire. In our case, it was a simple cylinder, and afterwards you do multiple layers of this. For instance, I think one layer of this laminate is around 0.2 millimeters. So you do 3 or 4 of these lamination steps, and afterwards what we did, since with lamination we could get the fibers to be in the direction of the rocket, what we did is to make sure that it has also axial rigidity, so anything pertaining to being perpendicular or in a non-axial stability. Sorry. Axial means that it goes along the axis of the rocket, and non-axial means essentially everything else. Since we are rotationally symmetric, this is the kind of loading terminology that we use. Yeah, back to lamination. So after the lamination, what we did is put the same cylinder on top of which we laminated to the on top of the 5-axis winding machine kindly provided to us by the chair of carbon composites. And what we did was we wound a 90-degree layer, which essentially means that it's completely perpendicular to the flight direction of the rocket. After this is done, there is still some post-processing to do, because as you can imagine, doing a 5-meter long tube would be very hard, and also it doesn't quite fit the 5-axis winding machine. So what we do is actually we structure the rocket into segments. These segments individually are usually about from 0.5 meter to about the longest one is, I think, 70 centimeters long, and they are interconnected using a 5-axis milled part. It is this tiny ring. It literally looks like a crown when you look at it. You essentially put those on the inside of the rocket, and there is two parts to them. One has a thread inside of it, which is provided by a helicoil. This is essentially just I think it's a steel insert that goes into a thread to make sure that it doesn't wear out. And on the other side, it is a simple fitting surface that fits on top of this threaded part, and it then gets screwed down to the other part. We use titanium screws because to get as light as possible and get as much apogee out of the rocket as possible. Of course, we try to save as much weight as possible. We save 2 grams per screw, like that, which might not sound like much, but when you have 100 screws in your rocket, you really quickly start gaining quite a bit of weight. 200 grams, as said, would be about the weight of adding another of those motor mounts onto the rocket. Both stages have a similar system. So on the lower stage, the system was developed initially for our biliquid project. We essentially just were able to take it over and implement it in our rocket. And on the upper stage, we simply scaled it down to fit the lower diameter of the upper stage. To talk about the diameters, I almost completely forgot. The diameter of the upper stage is about 146 millimeters, which is due to the fact that on the inside we actually barely reach, or on the inside we have about 142 millimeters. This is due to us flying a payload which is in a U format. A U format was developed initially for small satellites and designates a space of 10 by 10 by 10 on a payload. Also, if whenever you hear terms such as rideshare on top of rockets, there is probably these small tiny cube satellites that are being launched with like a larger satellite. For instance, a geostationary satellite which serves some TV station or some TV provider. With this payload, essentially we have a 3U system. So we have 3 of these 10 by 10 below each other. So essentially it's just 30 by 10 by 10 kind of space. And as already explained, they are doing the algae experiment. Yeah. Yeah.
And after that they will put in the igniter and then rocket.
Okay.
And we'll have a stage.
Okay, so I just got an update. We're waiting for getting a clear for launch from the safety, and afterwards we are inserting the igniter into the booster. Wow, that was a beautiful flight. We just had another rocket launch. That is a common occurrence kind of here, since we are on a rocketry competition. Yeah. Forgive the obviousness. But we are currently inserting the igniter into the rocket. The igniter, once it is inserted, will get a red flag status. I will zoom in on the flag right now. Just give me a second, and then I will be right back with you. So what I currently zoomed into is the flag that essentially designates the safety. I don't know, it's relatively badly visible, but it's a yellow flag on the back, on a very yellowish background of the bushes. This essentially designates that there are explosives on the pad and that the safety equipment is required. When this changes to red flag, that would mean that we have a igniter inserted into the booster stage and that every single system is armed. And essentially afterwards we will clear the pad and get everything ready for a launch. Currently we are waiting for a bit more updates from the Launchpad, but if everything goes correctly, then we are ready to fly. So flight really soon. I'm not sure. I think we are actually getting the APRS data. Yeah. So we are getting APRS data from both stages. So we'll be able to track the rocket kinda live, since we are not yet getting any telemetry. However, yeah, this wouldn't be this precise of a tracking. So we will wait until. So we will have to wait until afterwards to get the precise data on the flight. Yeah, we currently have a hold due to relatively windy conditions on the main pad, which is a single stage pad. However, as you can see, this is not for us, as we are still on the yellow flag. You will see the red flag come up hopefully soon. That is the moment we essentially are clearing the pad and getting ready for launch. So maybe to give a bit of background to the development and the effort that has went into us being here, Project WESP as a whole is a short for WARR Experimental Solid Platform. It essentially focuses on testing and verifying technologies that are not the main focus of NIXIS, our sister BioLiquid project that was already mentioned. So far we have had one successful flight before this competition. Currently we are on our second launch attempt ever with this project, which is quite exciting because what we brought here is kind of a complex system. The system that is standing here today was developed over the past half a year, I would say. With the booster stage actually being taken over from previous development. So half a year the booster was developed, and for another half a year we developed the upper stage. The upper stage was manufactured just 2 months. Started manufacturing just 2 months before the competition, with us getting the final components maybe a month before this launch. So everything here on the pad is essentially new. We are looking forward to testing everything that we've built over the past few months, and hopefully, if everything goes well, we'll be able to successfully recover and show a successfully flown rocket. Yeah, we are continually getting also announcements from the launch control. They essentially are also running a live stream parallel to ours. that is focused more on the entirety of the competition. You will probably, however, we will cover our launch to the greatest detail possible. So if you're here for this, stay tuned. So what was especially important to the construction of the rocket actually was the aerodynamics, since this is not our first supersonic rocket. However, this was a completely new team, and we essentially had to develop all of the skill sets on our own. There are two major components that always need to be, or we try to simulate to the best of our abilities. That is the nose cone. Nose cone is essentially the main aerodynamic component, especially when it comes to supersonics, as it reduces the drag that the rocket experiences due to shock waves, and enables us to go as high as possible. And then the fins are essentially the stabilizing component of the rocket, which means that, if you can imagine, if the rocket were to fly without fins, there would be nothing giving it backwards force to force it into a straight flight, or the original flight trajectory, which would mean that, well, what would eventually happen, right, is you have nothing forcing you back into your trajectory. So what could happen is your rocket flops over. That is the reason for the fins, and the fins are basically responsible for keeping the rocket on trajectory towards those 25,000 feet. If the rocket didn't have these, what could as well happen is that directly off of the launch rail, the rocket could flip over and essentially just land with a fully loaded engine on the launch pad. Of course, we have fins. This is not gonna happen. Whenever we talk about fins, what the main thing that is being talked about is the stability, and the stability is measured actually in calibers. Calibers, those who know, or for those who do not know, it's essentially the multiples of diameter of the rocket. The diameter of the rocket on the upper stage is set 146, on the lower stage 200. When they are together, we always take the larger diameter as the baseline measurement. A rule of thumb for the design of passively stabilized rockets is that you always have a stability of above 1 caliber. So that means that so what this distance illustrates, before we get to the explanation of what our rocket has for stability, this distance illustrates the acting point of the aerodynamic forces onto the rocket with respect to the center of gravity of the rocket. Essentially, you can imagine it, if we tilt the rocket, or if the gas tilts the rocket, we want to ensure that the center of pressure, acting point of the lift forces, is behind the center of gravity, such that it pushes it back to the original trajectory. On our rocket, and this distance is measured in calibers, again, so multiples of diameter. On our rocket, on the upper stage, we experience about 2.3 calibers of stability as the lowest point, and interestingly enough, as the upper stage goes more and more or faster and faster, it goes into supersonic range, where actually the stability increases upwards to 3.5, 3.6, which essentially means that we have the center of pressure about 45 centimeters away from the center of gravity. On the booster, which is arguably the more important, in terms of stability, the stability is about 2.3 again. However, we do not see that big of an increase throughout flight. We peak out at about 2.8, 2.9, since the booster doesn't enter supersonic flight. The booster stage goes off of the rail, and this is actually where we have the lowest stability margin throughout our flight, because it's kind of hard to imagine. However, as the rocket goes off, we go into a sheer wind. You can kind of hear it or see it blowing around me all the time. Today we have a quite windy day, and what happens then is that the rocket gets pushed off trajectory, and if the stability isn't high enough, which can or in some cases does happen also around here, what can happen is that the rocket will go into an like ever amplifying angle of attack, which just completely destabilizes the rocket and throws it off course. This is arguably the most critical point as far as stability goes for our rocket. So we will know almost immediately if we have a good enough stability for launch. The other part that is important for us actually is a requirement from SAC, which says that as we fly up high, before stage separation, we cannot have a angle of attack of more than 20 degrees. Yes, so, or not angle of attack, but actually angle of flight. So with respect to ground, we cannot have, or perpendicular to the ground. So 20 degrees is about this much, which you can imagine is kind of not that much, especially in this kind of wind, where the rockets have a tendency to tilt into that wind due to this stability margin. So the rocket afterwards should follow a ballistic trajectory. If everything goes right, we will separate at about 1,000 meters. The booster then goes on to, I think, about 2 kilometers, and then the sustainer goes onwards to those 8.2, 8.3 kilometers.
Right now at the two-stage Launchpad, from which team are you?
Sorry, it's hard to understand you. We are team 110. That's team 110. Your radio will be with us.
Copy that. We will, after Launchpad, we are going to bring it up.
Sounds good. Thank you.
Okay, so a short update from the pad. I think it was about coordination with some other team. I think it was with regards to the Yagi antenna that we have here. Actually, just to show you how that setup looks, we are currently having that Yagi antenna hanging from the top of our car. So just give me a second. I will show you how it looks. Sorry. So as you can see, Anibal is holding the antenna. As said, this is to receive the signal from the APRS trackers, which are on the rocket, and we use this antenna to track them down. They send data packets of their location, such that once the rocket lands, we are capable of even finding the rocket. Because if, as you can imagine, if the rocket doesn't recover for any given reason, we have a ballistic impact, which would essentially mean that we would need to look for a rocket that has dug itself about 2 meters into the ground. So we definitely do not want to experience that. Yeah, however, if everything goes right, we hopefully will see the main and can go directly in that direction. Yeah, I will try to hear an update from the, or try to get an update from the pad, since we should soon be going, and also tilt it back to the flag, tilt the camera back to the flag, such that we can see when the red flag comes on. So stay tuned, I'll be right back. Okay, so for the as for the pad crew, we got an update. They are in a launch ready state. However, we need a 50% or less cloud coverage, which currently isn't the case. Surprisingly enough, in the desert. So we are currently waiting for the go from safety. Afterwards, we will, I will immediately inform you, of course, once we have the go. You will probably also see it on the red flag. Once we have that, we are essentially gonna launch this rocket. To visualize how long we can stay on that pad, the cooling is going great. Of the payload, everything should be working well. The other thing is that we have batteries, of course, in the rocket to power both of the stages' computers. However, those have power for about 9 hours, so they should have no problem staying alive while we are waiting for the cloud coverage to lessen. So yeah, we are looking good. The only problem right now is the weather. So once that clears, we should be ready to go. So from the perspective of the preparations for this launch, specifically, for instance, for today, for instance, we always wake up at around 3 a.m. in order to get everything ready, and then we drive here early in the morning. As said, there was a hold up. We were slotted to launch at 7 a.m. However, we couldn't due to the hold up at the gate of the spaceport. Similar thing happened actually yesterday. So we came in relatively early. I think we were here already at 5:30 a.m. We left our house at 4:30, everything had to be ready by then. The guys that have so far been amazing, were the recovery guys, as they have essentially pulled an all-nighter in order to get the rocket into a ready state by this point. And so far today was actually less hectic, as we had everything ready from yesterday. And yeah, the only problem currently was, as said, receiving the signal from the computer. However, we do not need that to actually launch. So we are currently we want to make sure that everything is ready in a launchable state, and the moment we get a go from safety, as already said, we launch. It's slowly getting sunnier, so maybe soon. Yeah, the cloud coverage is kind of broken, but not quite. So yeah, once we have 50% cloud coverage, I will let you know, or once it starts looking like it.
Have you heard anything from the pad?
Cloud coverage is the only problem.
Okay.
50% cloud coverage or less.
We have currently a solid connection to upper stage. The big antenna really helps.
Yeah,
there a lot of teams have them?
Yeah.
Okay. I'll go take some water.
Yeah.
This and then.
I bring one to Anibal. Anything else?
You think I could get one sandwich?
Yeah.
They're still down there, or is there some up here? Oh, nice. Okay, afterwards.
Wir könnten wenigstens auf Lot stellen, während wir hier warten.
Warum?
Ich finde es ärgerlich, dass die noch nicht auf Lot gestellt haben. Jetzt geht der Wind sogar echt klar.
Der Wind ist egal.
Ja, ich weiß, die wollten.
Ja, ich glaube, ich will gar nicht sein.
Yes, das ist schon
Ich würde vorschlagen, dass am Mittwoch der Tatsache, dass wir gerade sowieso auf besseres Wetter warten und das wahrscheinlich noch ein Weilchen dauert, bis es kommt. Wir versuchen, die Kameras zu debuggen. Dafür würde ich sagen, bringen wir das RGS einmal hierher und gucken halt, ob wir, wenn wir das RGS hier lokal stehen haben, die Videosignale empfangen. Wir können dann halt mit einer Person, die bleibt, das Toggling machen und zumindest sicherstellen, dass wir gar keine Toggle in der unteren Stufe, also ich habe auch schon mal das Fliegen gehört, ich vermute, dass in der unteren Stufe eine Möglichkeit besteht, dieses zu haben. Aber da wir ja die Hügel haben und kein langer Fall, würde ich vorschlagen, wir fahren das RGS einmal rüber und stellen jetzt sicher, dass wir überhaupt Videoempfang haben.
Okay, dann probieren wir das. Irgendwie sieht das Wetter nicht aus. Dann komme ich mit dem RGS.
Habt ihr schon mal versucht, euch mit den Videoantennen auf dem Auto aufzustellen?
Haben wir noch nicht gemacht.
Probieren wir erstmal das.
Wie gesagt, hier habe ich echt schrecklichen Empfang. Ich glaube, es ist echt einfach irgendwie vielleicht auch im Zelt oder so. Keine Ahnung.
Also für dich auf der Cats Ground Station hat man da, wo gerade beschissen worden ist, ein richtig schlechtes Signal-to-Noise Ratio. Das geht wirklich deutlich besser, wenn man ganz woanders fotografiert.
Stellt die Cats Ground Station bitte aus der Mission-Kontrolle raus. Stellt die Cats Ground Station bitte aus der Mission-Kontrolle raus, damit ihr das mal noch gut macht.
Jetzt ist es wieder sehr gut.
Den Right-Heading Teleskop läuft. Also das Confirm ist, ja, dass halt da kein Empfang ist. Das ist dann vielleicht ähnlich. Ihr könnt euch also auch überlegen, ob ihr das Ding jetzt anders stellen wollt, wo der
Wir versuchen jetzt mal mit den Antennen woanders hinzugehen. Wir versuchen mit der Antenne jetzt mal woanders hinzugehen, also höher.
Ich habe versucht, glaube ich, das zusammenreißen, wenn er Empfang hat. Ich würde empfehlen, dass er da jetzt fest ist, wo er eine gute Signatur zu 9 sollte mit dem Kasten fangen.
Iren,
Ja?
die Cat Station kommt rüber, wenn du da besseren Empfang hast.
Ja, ja klar, also Empfang habe ich immer. Ich wollte bloß sagen, es liegt definitiv an dem Ort hier.
Ja. We have a power bank here, Benji.
Okay, what's the plan?
No, that looks
Yeah.
good-ish.
Me too.
Yeah, we just need like a break in the clouds.
I mean, the wind is also more subtle now.
Well, definitely better than it was.
Those
Just like a few meters in that direction. Literally.
But now they're too afraid to put on the red flag.
I mean, that is not a decision up to us.
What should we do? Or just put red and just rock it.
I mean, you cannot really do that. If nobody sees the rocket coming.
It's bloody weather. Really, like, how is it that yesterday we were cooked here in 40 degrees and now it's 25 degrees with clouds? The only thing missing would be rain.
That would be hilarious.
Now we left integration curse, now we're at launch curse. We were bringing bloody rain to the desert. It's not once in a lifetime, it's not once in a century, it's just every time rocketry comes around.
Okay, let me turn to the stream again.
Yeah.
Okay guys, here's a quick update. We have a call to put in the igniters and make the upper stage. Sure.
Where do we go to put in the igniter?
Okay, so just in, we have a go to put in the igniters, which essentially means that soon we will see a red flag. Yeah, from then on it's just launch operations. So I will try to keep you as updated as possible. Yeah, if it isn't clear, this essentially means that we either will have a go soon or go the moment we put in the igniters. So the moment I have the confirmation that they are clearing the pad, I will start the timer. Yeah, as said again, the problem is that it is very hard to estimate when we will get to launch, as we are in essentially a queue of rockets trying to launch. However, the moment I know exactly when we are launching, I will let you know. The current as it stands right now, so putting in the igniter is a relatively trivial task. We essentially, so igniters are essentially smaller rocket engines that ignite the solid fuel inside of the larger engines. These are usually, you try to insert them as much as deep as possible into the engine, such that we have as good of a chance of igniting as possible. For the upper stage, this is especially true because, as said, we have no way of troubleshooting this. So in case the upper stage doesn't ignite throughout flight, we essentially have a failed ignition, and we won't get to do a retry. Since we only do get allotted one flight per this competition. The competition itself is so far on hold. It's not just us. It's the entire competition due to the cloud coverage. But they do have forecasting that is quite possibly more advanced than ours. So we are waiting for their go. The way it currently looks is, the cloud coverage is slightly breaking up in the distance. So this is probably why we are allowed to put everything in. Once the red flag goes up, I will come back to inform you more on what exactly is going on. I'm really sorry for that one. Yeah, so to repeat, we are currently have a go to insert the igniters into the rocket. We are hoping that very soon we'll get the go from the launch control and safety to essentially put up the red flag, clear the pad, and get ready for launching. The weather is the problem, as already said. The cloud cover needs to be less than 50%. However, what is my best guess anyway is that the clouds are slowly breaking up in the distance, so we might get a window for the flight. Of course, this always depends on launch control or the safety of the competition, and it's not just us that are on hold. The entire competition is currently on hold. All of the solid pads, all of the liquid pads, and also all of the two-stage pads. As we will currently proceed with integration of the igniter, which should be finished relatively soon, and afterwards we will be hopefully putting up red flag soon, getting clear of the pad, and launching this rocket. I will see if there are any updates. The information has been relatively scarce, but in case there are any, I will make sure to include them. So stay tuned. I will be right back. Okay, so just in from the pad is the info that they expect better weather in about 30 minutes. So I'm gonna reset the timer and see if that holds. And yeah, so after these 40 minutes, we should be ready to launch essentially. So 30 minutes of hold due to weather, and afterwards we clear the pad and get ready for launching. So if everything goes right, we should be ready within about 40 minutes. So, as for the competition, I think I forgot to mention it today. We are competing in the category of 30k COTS. 30k essentially means 30,000 feet. That is the target apogee that you're trying to reach as precisely as possible. Some teams actually employ air brakes in order to achieve this, because they have enough energy from their motors, and so for the COTS, what that stands for is commercially off the shelf. That stands for usually that designates the engine. For us, it's commercially off the shelf solid engines. Usually those are the only ones that actually commercially exist. But then we of course have self-developed, so self-research and developed category SRAD, which is some of the teams here. Most prominently, probably there are in total 7 hybrid teams, 2 that we've seen launch today. I do not remember how many managed to launch yesterday. Those things have quite long burns. You can essentially hear them go all the way up. That is actually launching a bit away from the main event, similar to us, as they need to fuel. They need to do a lot of operations that similar to our sister project Nixus, that are relatively unusual for solid rocket motors. For us, it's preparing the grains, inserting them into the motors, or into the liners, and then inserting the liner into the motor, which can all happen beforehand, before we are standing on the pad, and we can essentially just come here with all of our equipment ready, and this then is way easier to handle than a hybrid or bi-liquid project. Since I mentioned Nixus, our bi-liquid project, I also want to congratulate them on getting accepted to UROC. So similar to give a bit of background, we have a sister project, Nixus, a bi-liquid cryogenic rocket which burns ethanol and liquid oxygen, and this rocket takes part in the annual European rocketry competition, UROC, and that is hosted in Portugal. They have successfully gotten accepted for this year, so look forward to another launch this year, later this year, when our team will be fueling an actual cryogenic rocket on the pad. Currently, actually, they are testing and hot firing the latest iteration of of our flight engine called Brunhilde. This engine essentially produces about 3.5 kilonewtons of thrust. So for a rocket of even greater weight than ours, this is actually why you usually see those long burns on hybrids and bi-liquids, as in order to get all of the rocket into the air and get it up to speed, it takes quite a bit of burning fuel. So the rocket itself is, as said, a bi-liquid cryogenic. It is about 6 meters long, so again, the sister project Nixus, and last time around, I was there as a spectator. We could. It was actually very beautiful to see the rocket being fueled up, as you see this puff of condensation just streaming out of the side of the rocket, and it getting fueled up to full. That was quite the experience. Okay, but back to our launch. So even though we do not have such a complex PET procedures, there is still a lot of stuff that needs to go right, especially from the perspective that we do not get a privileged treatment here. The moment we show up on pad, there might be a queue of rockets, there might be people waiting to launch. For instance, yesterday that was the case. What happened? We wanted to launch at 9 a.m., but when we came, there were already 5 teams lined up, ready to get going. So this time around, it was actually just 2 teams before us. That is why it got postponed all the way to now. However, if all goes right, we are the next ones to launch. So far everything is looking good. I mean, the only thing that is not working, unfortunately, is the live telemetry, and live video, which we won't be able to stream. However, other than that, I will try to capture the rocket as good as possible, and if everything goes right, we'll launch in about those 30 minutes. In the distance, I can see the cloud coverage kind of breaking up. So if the weather will comply, we will quite possibly be launching in those 20 or so minutes. We just if you probably seen the car just driving past. I don't think it had anybody on board from us, but it was ESRA officials. They are coming back and forth between the pad and the launch control to exchange information, give supplies and stuff like that. Hopefully we'll get more updates on the weather situation soon. Until then, we are sadly kind of limited to whatever trickles down from the pad crew. But of course, if I get any new information, I'll let you know. Okay, to talk about something else than just the rocket, there is a lot of stuff that goes into launch that is not really rocket related. Best example being the Yagi antenna that we are currently holding up to catch the signal. We essentially need to build out all of the infrastructure that goes into launching a rocket. So specifically, this means communicating with the primary flight computer, being able to ignite the engines, being able to track the rocket, for instance, is a good example. And for us, what is especially true, we have built out our own interface when it comes to communicating with the rocket, called EXUI. This is essentially a web app that allows us to directly communicate with the primary flight computer. If we receive the telemetry and signal, we are essentially able to live stream that data into that web app, and are capable of essentially making the saving the data live also, and transferring video. That was what I wanted to say. The video part of the telemetry parts are currently sadly not working. However, what it is also used for, which then goes back home to Project Nixus, is also controlling the components inside of the rocket. So when it comes to the biliquid rocket that Nixus is flying, they have a lot of pressure sensors, a lot of temperature sensors inside of the rocket that get routed through the primary flight computer, which then sends this data onwards to EXUI, and this then displays all of them. This system is also used throughout our testing. So whenever we test the engine or test any component inside of the rocket, we use this system in order to verify and validate, or essentially transmit the data and evaluate the data that has been transmitted through the system. This rocket doesn't have that much data that it needs to transfer, except for its position and its except for its telemetry and status of the recovery system. However, it is still extremely useful tool for us to essentially know what is the status of the rocket and being able to control our rocket through it. I thought we were getting an update, sorry. Sadly, no. This rocket specifically essentially uses it as a communication platform for the ignition. So whenever we shoot or whenever we give the command, the primary flight computer triggers, and so the igniter actually is wired directly to the pad of the booster stage. But for the second stage, we essentially then use the primary flight computer in order to trigger the sustainer, so the second stage. This is with regard to the we ignite actually using just a wire directly provided by the competition. The booster gets ignited manually. However, after launch detection, primary flight computer takes over, and once it detects separation, or when it hits a timer, it ignites the sustainer. So that is kind of the after separation. What happens is completely up to our self-developed flight computer, and that is one of the critical parts inside of the rocket. I'll try to see if we have more updates on the weather. In case not, I'll be right back. Okay, so I'm now going to try to call Ludwig, our project lead, and see if there are any updates for the past 15 minutes. I mean, the weather is actually starting to look better and better by the minute, so maybe they got an update. Just gonna try it. Ludwig for stream. Any updates on the situation? I'll try to get higher up. We do not have line of sight, so it can be also that the radio just didn't pick it up on their side. Just give me a second. Ludwig for stream, any updates from your side?
We're still on hold due to bad weather. Give it another half hour, 2 hours.
Understood. Okay, so yeah, even though the weather is improving, apparently it's not enough. So yeah, once we have a confirmation that the weather is good enough, I will let you know. Yeah, we do have the radio from the competition directly here, so hopefully I'll be able to catch it. And yeah, afterwards I'll just directly come here and notify you guys. Yeah. So to talk a bit more about the rocket, since we apparently have the time. So as said, we have two recovery systems which have a very similar functioning. The way these recovery systems work is that actually when they deploy, the drogue is usually just freely stowed away in the or either freely stowed away or attached to a bag that then gets pulled off due to a recovery event. For instance, nose cone getting shot off, or the hatch deploying. But the hatch in this case actually just pulls out an uncovered drogue. Afterwards, what happens is that the drogue kind of inflates and pulls out a shock cord. A shock cord is essentially a damping connection that connects the drogue to the rocket, and yeah, it's the main line of defense, let's say, against the shock forces produced by the parachute openings. Yeah, afterwards we glide, or essentially just hang from the drogue chute, falling at I think about 30 to 40 meters a second, if I remember correctly. And afterwards we have so after when we get to 300 meters, we use a release device. This is a pyrotechnics device that essentially uses a charge in order to disengage itself. When this happens, the drogue's drag and the drogue's force pulls out the main parachute, and a second shock cord essentially gets pulled out with this main parachute, decelerating the rocket, again protecting us from the shock forces. The shock forces are a quite significant topic. For instance, during our simulations, we predicted that we might get up to 4 kilonewtons of recovery force, which is a non-insignificant amount. That's like momentarily weighing a 400 kilogram weight on the tip of the rocket. Yeah, that's why actually we did the previous launch to verify the calculations that we did so far, and essentially verify the recovery system in and of itself. the booster stage has essentially the same system. So after the drogue deploys, the rocket glides below the drogue, and then a release device triggers, deploying the main parachute of the booster stage, and it glides down to a safe touchdown. If those parachutes are pretty big, so especially for those parachutes are pretty big, since they need to slow down 25 kilograms or around 20 kilograms of rocket twice. So yeah, if all goes according to plan, we will see those touching down somewhere around us in the desert. The recovery then goes as follows. So after the rocket has touched down, we need to wait, of course, for the rest of the competition to finish their launches. The launches usually take about 10 to 20 minutes. So in case we are first to launch, we'll have to wait a while, and then we can start what is called a recovery mission, which is us using the APRS trackers, so the GPS signal sending tracking devices, or sending devices, that to find both stages of the rocket. The booster we are not that afraid about. What we are afraid about is especially the sustainer, which where this sustainer is specifically prone to flying off. Since it goes to about 25,000 feet, it will have a lot of time to either fly quite far away or glide quite far away due to the wind on the parachute. So yeah, currently the timer says 15 minutes, and the weather is kind of looking better and better now, but I will reset it to what Ludwig has told me, so minimum of 30 minutes, and yeah, on top of it, clearing the pad, so 40 again, and we'll see how that goes. Afterwards, I'll try to get a bit more information on what is happening at the launch pad, and if from our side, except for the telemetry and the video, everything is going smoothly. We are ready to launch, so the moment the safety range gives clear, we are launching. For those who have newly joined us, so we are standing currently on the launch pad with our rocket, and as it stands, we are currently on hold due to weather, as we are waiting for cloud coverage to clear and also the wind to die down a little. As you can see, the sun has come up and the clouds are kind of breaking up, but it's not yet perfect. So yeah, I'm gonna increase that timer to a more reasonable time and try to get an update as soon as possible on when the hold might be ended. So yeah, hopefully soon. We are all looking forward to this. So, hi there. Let me activate the camera. Okay. Sorry for neglecting the chat up until now. Actually, please, in case anything is unclear, I will try to answer anything from now on. Sadly, it doesn't. The chat doesn't transmit directly to my streaming platform, so I cannot keep track quite that well. But there was an announcement. Sadly, I didn't quite understand it. It was a short one, so it probably wasn't with regard to the hold. Yeah. So, in case you had any questions with regard to the to the explanation, feel free to ask any questions. I will try to answer them. So, there was a comment about it being very windy. Yeah, so it is quite windy here actually. I would estimate it at about 20 to 30 kph, depending on the gust of wind. But yeah, it should be kind of okay to launch, as we have quite the stable rocket. So the only worry is that we might tilt a bit too far into the wind. However, yeah, that is currently a secondary issue, as we are trying to get everything ready for a launch. Still the yellow flag, which means that we are still on hold. Yeah. Current launch status is that we are fully ready. So from our side, everything is ready. We have GPS track. We have APRS track, which essentially means that we will be able to find the rocket afterwards. The only problem is that we are momentarily on hold due to bad weather. This is due to cloud coverage, not as much as the wind. However, yeah, the wind also could cause some launch outages. Yeah. So the hold is predicted to end in about 30 minutes. That's the timer currently, as it is very hard to predict when exactly. Yeah, but from our side, we are essentially ready. The moment that they give the go, we clear the launch pad and we move over to this post, the mission control area, and get ready to launch the rocket. Yeah, so no new updates, sadly. Yeah, as we are currently on hold, a few of the team members are currently enjoying a bit of a sleepy time. Yeah, it is kind of necessary since we are up from about 3 o'clock in the morning. We essentially do not get quite as much sleep as we would like. So yeah, whenever there is a chance for a shut-eye, we always do try to get some sleep. This is out of necessity, and yeah, also probably Nix's launch crew from last year's Zero can attest to, if it's possible, you always try to get some sleep. That's the main goal that you try to do while being here. Okay, so once the timer hits 30 minutes, I'll put it on hold because that's what I kind of expect. The time once they give clear from so once they give us the clear for us to launch. Yeah, that would be about the time it would take us probably to get everything ready. It's just an estimate. It's really hard to get a clear estimate on that, as we are not here alone. We do not control the airspace. With regard to that, the cloud coverage is again getting a bit worse, which is not ideal. Hopefully it will soon clear out. That is the only thing holding us up for those who are newly joining. As far as the readiness status is, I haven't received any more updates, and I think there won't be any more updates with regard to our readiness status, actually, since the igniter is inserted, and that is literally the final step that you do before launching the rocket. The only thing that we're missing is for the competition to be cleared from the hold. Oh yeah. So there is a kind of an update on the payload, which is essentially that it is nominal, which kind of might sound boring, but since it is an actively cooled payload that needs to remain below 20 something degrees Celsius in the desert, we need to essentially constantly pump water through it, which is not ideal, especially in electronic systems, which are very, very prone to failing once they get soaked in water. That is a good news from the payload. In case anything else comes up, of course I'll keep you updated. Check the satellite?
No, but look at it. Clouds keep coming. They close at noon here. No one launches in the afternoon. Tomorrow will be the same weather, even worse, all cloudy. And Saturday, mostly cloudy, maybe some breaks. And Saturday is the last launch day.
Yeah.
There's a good chance we'll never fly.
It'll be so shit. I love how that side is perfectly good. Yeah, we need to wait here. There's no other way of doing this.
going?
Alex.
Is Richie now going?
No, we don't need to send a representative because we coordinated with Jim directly.
Yeah.
Yeah.
What are they saying?
I don't know, I have heard updates since, but I suspect it will be no.
No launch.
I mean, look at the weather. Although it would be amazing to see like on onboard footage like how the rocket just flies through the cloud and comes out at the other end. I highly doubt they let us just shoot into the blind. Well, I'm gonna look for a suitable bush to do this. Nehme ich mal Holz.
Bitte?
Der Hering hier.
Welche? Vermutlich.
stream like that, Benji. There has to be 100% coverage. I told it to you.
Yes, I was eating an apple when you came. I
Yeah,
cannot
but then
go hungry.
put someone else in the stream. That's not so difficult.
They are sleeping.
Yeah, then
They
wake
are
them up.
preparing
That is
EGSE.
important.
Yes.
Don't you? It looks like you don't understand that. That is important.
Yeah.
There has to be someone, even better, 2 people in the stream all time.
Yeah. Go ahead. Let me mute this. So we have the project lead Ludwig here with some messages with regards to today.
Hello everyone. Again, when I come in the stream without the good news, the wind is increasing. We're right now looking at 10 meters a second and the cloud coverage is close to 100%, which means that the officials from Spaceport America just called off the launch day. There will be no launches happening today. That of course includes us. We were sitting on the rail now for several hours without getting the go from their side. We would be 100% ready. We're right now taking the rocket down again and we will load the rocket up back on the truck and we'll be here from tomorrow 7 a.m. onwards again. So you can expect the 3rd stream there. Unfortunately, today's stream is going without the expected ending, and yeah, we'll try again. We'll go home now, we'll get some sleep, recharge not just our batteries but also the batteries of the vehicle, and then tomorrow we'll be here with an even better setup and we'll be even better prepared to finally launch that vehicle, as we're already 100% ready for launching. So yeah, sorry for today and I'm looking forward to see you tomorrow again. Thank you.
Okay, so yeah, in the end, the window that everyone wished for didn't open. So I'm really